I'd like to now introduce our third speaker. Steven Tateosian is the CSS ICW MCU VP at Infineon. The topic of Steven's talk is Infineon's RT-Thread MCU support. So at this time, I'm going to say over to you, Steven.
Okay, can you hear me okay?
Yes.
And I assume you can see the presentation now as well?
Absolutely.
Or at least the cover slide. All right, so thank you all for attending today. And I am personally excited to be here to present to the extended audience as well. So a little bit about myself. What do all those initials mean? Essentially what it boils down to is I run the IoT and industrial microcontroller business here at Infineon. And today it's my pleasure to walk through a bit about Infineon. Let me go to my agenda slide here. So a little bit about Infineon, which I really appreciate the discussion around how much power all of this data that is being created and collected and stored consumes, because this is really at the heart of some of the activity here at Infineon. Then I'm going to talk a little bit about our MCU portfolio as it pertains to consumer and industrial and IoT applications, and then finish up with where we are with our RT-Thread support in terms of hardware, software, BSPs, and ecosystem. So first of all, and this is I think coincidental that the discussion went to the amount of power these systems are taking in the future, because of the amount of data that we're collecting through these tiny little edge nodes. Infineon is focused on two primary activities, one around decarbonization and one around digitalization. And those two things together, and I really like the way Clive put it there, that the architectures that we have developed and deployed today, whether that be for IoT, low power sensors, or that be for power supplies in server farms, will be different in the future. They will need to be different because of the environment that we live in and the power that is consumed and will need to be consumed on the trend that we're on right now. So this decarbonization and digitalization are both at the heart of what Infineon does, and I'll have some slides showing that a little bit more in detail as we go through the presentation. With, of course, the objective here to make our lives easier, safer, and greener with our customers and our partners for a better tomorrow for all of us. So Infineon's position is a global leader in automotive, power management, and energy efficient technologies for IoT. So overall, #1 supplier for semiconductors into automotive, into power applications, and then #5 in microcontroller outside of automotive. So if we exclude automotive from that business, so that's specifically the portfolio that I'm going to talk about today. This #1 in power and our strong position in microcontrollers does actually help us, help you reduce the power consumption of the end devices that you're all involved in, whether that be, again, at the edge node collecting the data, or the server or the storage systems that are maintaining and manipulating and analyzing all of that great data. So when we look at this, being the core of IoT and then driving this activity around decarbonization and specifically digitalization with respect to the MCU portfolio, you see here, the example that we have a wide range of real world end applications. And what Infineon brings to that here in the middle of this slide from a software ecosystem, and that includes RT-Thread, both from a software RTOS support, but also from an ecosystem perspective. And then Infineon also brings a set of sensors, be that from radar to CO2 to audio, meaning microphones and beyond, as well as actuate, so power systems, and then compute and connectivity. So a broad MCU portfolio, as well as industry-leading connectivity around Wi-Fi, Bluetooth, and combo devices as well. Okay, then of course many of you may already be aware of the strength in security across a wide range of applications, from identification to payment and embedded security in our processors. And then how does that connect to this digital world, and where all those nuclear power stations are going to be required in the future, apparently, in terms of where this data gets stored and manipulated. So again, I think one key message from this slide that I want the attendees to walk away from is that Infineon's position here around the middle of this slide, in terms of bringing a complete hardware and software solution to our customer base. And what we like to say is we like to meet our developers where they are. So it's not a one size fits all or a one approach fits all. It's ability to bring an ecosystem of support to those who are developing on our products, so that we can help them work in the environments that they work in and get their products to market faster and at lower cost. Okay, I'm going to talk a little bit about the Infineon MCU portfolio. So first of all, again, this is a little bit the same, just to show you where we are in terms of the different competitive landscape here. And again, I'm going to focus here on our IoT and industrial MCU portfolio, where today we see ourselves, based on the publicly available data, kind of in a number 5 position. So a strong position, and I think the key message here is that this position is strengthened by our ability to bring system level solutions, whether that be combinations of hardware, operating systems, ecosystem, but also the system level design and support for our customers. So more developers, our intent here is to enable more developers to get more products to market faster. So integrated software for lower cost of ownership in development and ongoing maintenance. We completely understand that the decision-making process around a microcontroller is different, for example, than perhaps a MOSFET, that this is an investment decision for our customers, because once they decide on a microcontroller, it means that's when they assign engineers to develop code, and that code they want to be able to reuse and maintain across a wide variety of products. So bringing a broad portfolio, enabling our customers to, again, find the products where they are in our portfolio and reuse their software investment, is an important part of our thinking and our capabilities when we bring products to market, and as we expand our ecosystem. Next, I'll say, high reliability, low power networking for high quality. So this is about connectivity integration primarily. So the way our products work together with the rest of the portfolio, for example, if we look at IoT applications, that is, the same software ecosystem and development environment for our connectivity devices as our microcontrollers, and how those work together, and how we've enabled the software to work seamlessly across the devices is an important part of this for IoT applications. And then, of course, a wide range of tools, well-documented products, and the appropriate certification. So certifications may mean, connectivity certifications around FCC, for example, or UL. It may also mean certifications around PSA for security, or FIPS, for example. So we like to, again, bring not just the capability, but the confirmation of that capability through the appropriate certifications to help our customers design with our products in a confident way, and do so in a way that will also save them time in terms of their end application certification requirements. I mentioned the integration of our MCU and connectivity portfolios, enabling faster time to market. And then, of course, the differentiation in our product portfolio, which I will get to in a minute here as I go through the content. So Infineon overall has a pretty broad MCU portfolio. This is a combination of what was the Cypress Semiconductor MCU portfolio. So you may all know that Infineon acquired Cypress about 3 years ago. So that brings the PSOC microcontrollers into this Infineon broader portfolio, and you can see those kind of towards the bottom of this slide. And Infineon, of course, had a strong position in industrial applications with the XMC microcontrollers, and then in automotive, the RX and Treveo microcontrollers as well. And those specifically, the RX and the Treveo microcontrollers also span some of the industrial applications, as well as they're a good fit there because they offer things like functional safety for, let's say advanced industrial applications, perhaps like robotics as an example. Today, I'm going to focus on specifically on a couple pieces of the portfolio here around IoT and industrial. Here we have 4 mainstream product families in the portfolio that we continue to invest in around software, new products, and the ecosystem. And this discussion today around, of course, RT-Thread is about part of that ecosystem support on our PSOC 6 family. So if I start on the left, we have our popular PSOC 4 family. You may all know this family. I think it's world famous for the integration of the high level of programmability of the SoCs, but also world-class CapSense or multi-sense IP embedded in these products. Primarily, these are a strong fit for a range of consumer or end node IoT applications. Sitting next to that in roughly the same kind of performance range, we have the XMC 1000 series. These products are primarily targeted at more industrial or motor control type applications. So they bring special features like math coprocessor paired with the M0 as an example, true 5-volt support, and a broader set of industrial peripherals. And then if we go up in performance, we have the PSOC 6 family, which is a dual core family of M4 and M0 plus devices, up to 2 megabytes of flash. These we really see paired quite often with our connectivity portfolio, again, whether that be Wi-Fi, Bluetooth, or Wi-Fi Bluetooth combo devices for IoT, low power IoT end nodes, and really bringing low power capability, still integrating our world-class CapSense technology and programmability up from the PSOC 4 family. And then on the industrial side, we have the XMC 4000. Again, I think one of the key features here for industrial is the right fit for the peripheral set here, as well as a very unique capability around EtherCAT support. And then recently, the end of last year, we launched the XMC 7000 family, which is up to a dual core M7, Cortex M7 family, up to 8 megabytes of on-chips flash. So really high performance capability for real-time control, safety critical applications, as well as industrial connectivity. So really, again, here, the key thing I want to leave this slide with is a broad portfolio of IoT and industrial focused MCUs. So I'm confident that as you start your next project, you will indeed find a strong fit for your end application. I really like this slide because I think this really speaks to the opportunity here for RT-Thread specifically, and really shows what I think we see on a regular basis happening in the market in this transition from MPU to MCU. And, I can build on this a little bit with this TinyML or Edge AI concept as well. I think this is really unique opportunity and time for us to all be working in this kind of embedded space for a couple reasons that things are really coming together in a unique way right now in the industry to support this transition from MPU to MCU, and from, of course, then from Linux to RTOS. I'll just speak of a couple of those trends, but first I'm going to talk to this, this 2.5 billion power constrained IoT devices are expected to ship with TinyML chipsets in 2030. So, there's this market research, you see where this is coming from on the slide here is publicly available. But my point here is, this is happening right now around us, and it's not happening in an ad hoc way. There are some fundamental things that are happening around the technology that are enabling this. So first of all, the story that I like to tell is that the compute performance, it's with Moore's law has long, the long-term trend has been pretty consistent in terms of increased compute performance. The unfortunate thing, however, especially in some of these higher end systems, is that as compute performance goes up, so does memory footprint or OS overhead. So the realization of that increased compute performance doesn't necessarily show up in the end application in a material way. That's really changing right now with Edge AI or TinyML, because we have two things happening simultaneously. We have more compute performance being loaded into MCUs now, and that could be through brute force, just higher frequency, main CPU, and or it could be through coprocessors for things like, and it could be a DSP coprocessor, I think more historically. But I think what we're seeing and going to be seeing more and more as we go forward is that these will be neural net coprocessors for machine learning acceleration. So we have a real resurgence in MCU hardware that is enabling the types of performance that happened to be only available previously in MPUs. And because of that, we're also then starting to see the types of peripherals or high-speed peripherals specifically that we used to only see on MPUs in the market start to show up on higher-end MCUs as well. And now combining that with the fact that, and I caught the tail end of the last presentation and couldn't agree more, with those some of the comments around, the lightweight nature of this software. So we're seeing, the ability for TinyML to be in the kbytes of memory, right? And not to say that you're going to do a multi-person tracking ML model with single-digit kbytes of memory. However, as they get with TinyML, those types of advanced ML applications will indeed and already are fitting into microcontrollers today. So it's kind of a win-win for developers who can really remove much of the complexity of designing with an MPU, much of the overhead in terms of cost, and of course move to a much lower power system solution without sacrificing, and frankly speaking, with some of these new accelerators, actually finding an uplift in overall performance of the system. So delivering in the end a richer user experience, or perhaps a safer user experience, or perhaps an actual real-time deterministic user experience, if that's what's required, for example, in an industrial application. So I think this is a super interesting time for us in the market, and I think RT-Thread is there to help the industry make this transition in this portion of the market. So with that, I'll talk a little bit about where Infineon is right now. We've clearly recognized the opportunity here to be part of the RT-Thread ecosystem. We have support today on our PSOC 6 family, which again is kind of our mainstream portfolio for low power connected IoT applications. The BSP is available in RT Studio, including the user guide and reference design has been published. The base hardware is a PSOC 62 cost-effective EVK or EVB as stated here. And we are planning engaged in a joint roadshow, ecosystem conference, and university programs as well around promotion of RT-Thread on PSOC 6. You can see some of the milestones here, fairly new to this, but moving pretty quickly. So within the last year, we've really embraced the ecosystem here. And made, I would say, significant progress. And again, I'm really happy to be here at this event today presenting. And we will continue to expand our support, not just for the PSOC 6 family, but for additional devices as well across our portfolio. So again, totally understand and value the fact that when our customers make an investment in their software, they want to be able to move that around a portfolio of compatible devices, and that's part of our value proposition as Infineon. So what does that look like? This is our EVB. So again, well-designed, low-cost EVB for RT-Thread support. There's a wide range of peripherals available, not just on the MCU, but available on the board, or accessible, let me put it that way, directly from on the board itself. And then, I think really nicely built to offer a range of expandability options, whether that be radar, CO2 sensors, wireless connectivity being, Wi-Fi combo, security such as our Optega TPM device or Optega Trust devices, and then the opportunity to add things like thread and matter over thread support as well. So a wide range of Infineon provided add-on hardware as well as third-party hardware to connect to the RT-Thread P62 kit here. Again, with the intent, and I believe this is not just an intent but a reality, to enable a really fast time to market and at least in a seamless development experience for adopters. So that is my last slide. I want to thank everybody for your attendance and attention today. And I can say that from a personal perspective as well as from an Infineon perspective, we're very much looking forward to more cooperation with the RT-Thread ecosystem. Thank you.
Well, thank you, Stephen. Very, very interesting indeed. I must admit, I'd forgotten that Infineon acquired Cypress 3 years ago. I had a friend who worked at Cypress, and those PSOC devices are absolutely amazing. I used to do, I'd write a blog on a Friday saying about a project I was thinking of doing, like on the Amazon. I'm not going to mention the name because I don't want to wake her up, but the microphone array on the top. Yeah. And by Monday, he got one working. He'd gone home and broken out his PSOC development kit. And he just whipped things together with those devices. So many people kept on telling me I ought to use them, but so many fun things to do and so little time. We have got a couple of questions that have been posted in the chat. And I want to tell everyone, if you've got questions, you can post them in the chat, or you can raise your hand on the interface, and the RT-Thread team will grant you permission to post your question live. The questions that have come through on the comments, where can we buy Infineon MCUs or development boards?
Yeah, so they are available through the Infineon site, and then of course through a variety of distributors and e-tailers, so the likes of Mauser and DigiKey.
And is there a partner program for development boards, or is it possible to collaborate with a university?
Yes and yes. So I'm not sure the question here, but if yes, there is a partner program. So if you want to partner with Infineon around a PSOC development board, for example, absolutely. We do that. And then, of course, we work with universities too. And I don't know if that was one question where a university wants to build a partner board. We could explore that as well.
Hmm. I, I I come from the days before microprocessors existed. And so I saw the first ones come online, the 6502, the
Yeah.
8080, and we thought 8 bits was incredible. you know, the first computer I saw that I had the possibility of getting, except I was a student and I didn't have the money. It was a single board development kit, and it had 1K of RAM and 2K of ROM. And I think it was 100 UK pounds. And at that time, I thought I will never be able to afford my own computer.
Yeah. Yeah, I was going to say that's not your $10 EVK there back then, right? It's a different
No.
world today for sure.
And the things you can do with today's processors, like your Infineon processors, when AI kicked in, everyone was thinking you'd have to have workstation class machines or cloud machines. And now with things like TinyML and all the new algorithms that are coming about, you can create a very powerful little AI system that runs in a couple of kilobytes.
Yeah, you really can, and you can do that in, that, let's say, in a wide range of applications, right? And it can make those applications could be more user friendly, or again, safer, or frankly, I think the example around predictive maintenance brought up in the previous presentation was spot on, right? We can use that kind of intelligence now in these systems to help these systems last longer, frankly. So, or run smoother, or even run more
Mhm.
efficiently while they are running.
Yeah,
Yeah.
yeah. I mean, one of the things I think I fall into the same problem that a lot of people do, that we see somebody doing something like the predictive maintenance, and they use an accelerometer, and we go, oh, that's a good idea. An accelerometer, you can tell if the bearings are going through the vibration profiles and everything else. And we get locked into the one thing. We think, oh, everything is going to be accelerometers. But when you think about it, I mean, I've worked in a couple of factories in my time, and there used to be the old engineers, the grizzled old engineers. And yes, they'd be walking around and they'd put their hand on a machine like a generator. And just by the feel of it, the vibration accelerometers, they could tell something. But they'd also be listening.
Exactly.
Yeah,
Yep.
and they'd hear a sound that, I mean, in a factory, this sounds all over the place. I mean, clanking and banging and this and that. And there'd be some sound that wasn't right. And they'd look around and go, where could that sound be coming from? And yeah, so I think we've got to open our minds to all sorts of sensors, like audio sensors, using the AI to spot
Yeah, I
something
think
weird.
there's some university research out there now. I don't know if I call it research, but it's a paper around kind of what sensors can learn the most about our environment, and microphone is right up there. And I think as people start to think about it, it's like, wow, you really can learn about a lot about what is going on in an environment based on the sound. I will
Hmm.
say, at the last TinyML Forum event in San Francisco in March, Infineon recently acquired an AutoML company called Imagimob, and they presented at the TinyML event with a customer of theirs that was using microphones to detect weld quality. So this comes back to
Oh, wow.
really senior expert welders can determine the quality of a weld based on how it sounds while the arc is present. And it's really amazing what can be learned. through audio. And some of that audio, frankly, I think also is audio. When I say audio, a microphone can pick it up, but perhaps a human ear can't or wouldn't be comfortable picking it up. So absolutely, I think there's a lot of to be explored, let me put it that way, opportunity for microphones or audio sensors paired with TinyML to really add a lot to environmental knowledge for a variety of systems.
Yeah, questions just come up here. Any Infineon board with MIPI, RFFE? Somebody else is asking microphone to detect what quality. I don't know what quality microphone to use, but I think as you said, Steve, maybe not just going for the human audio range, because I mean, our sensors are relatively limited. So a microphone that could also extend into the ultrasonic range could be of interest.
Yep, absolutely, absolutely. So I'm just looking at these questions. I'm not sure to detect what quality. Okay, I think maybe that's to the weld quality. So the quality of two pieces of metal being welded together. So whether it's a weld through or there was spotting in the weld, I think that's the question. So
When I was a student, I was on what they call a co-op course in the UK. And so I was in college for 9 months, out for 6 months, in for 9 months, out for 6 months, in for 9 months. And my first period of training was at Rolls-Royce Aerospace in Filton down near Bristol. And they were telling us that they had a department when they were making the blades that go in the big jet engine turbines. They got all the testers in the world, ultrasonics, sending, sound into the things. And the very final test was a room with these old engineers who were blind. And they would pick up the blade and I'm closing my eyes, which is stupid because they were blind, but they would run the fingernail down the blade. And from the vibrations, they could tell if there was a crack inside the blade and say, no, discard that one. And then as a post process, they'd cut the blade open and find what the fault was. And that would be something that might be coming up soon as well. There's a company called Bebop Sensors that have created something called Bebop RoboSkin, and it's a sensor skin that goes on a robot hand, and it has a finer resolution than the human hand. And I've seen a robot finger reading Braille, which just blew me away.
Really interesting.
I think we're poised at the beginning of an incredible new world. Well, one question I would ask the audience at the minute, but also you, Steve, have you got any familiarity with using a generative AI to help in developing code?
Yes. The answer is yes. Not production code by any means, but I think some of these for basic, let's say code, some of these generative engines today are quite adequate at doing that. And it's something that personally, frankly, I played with. So yeah.
The funny thing is, I mean, the one generative AI is one that takes a load of model, a load of source and analyze it, and then can generate new things. And there are ones that generate art package, pictures or text. And the one that's on everyone's lips, of course, is ChatGPT. And the funny thing is that, I mean, if you go and talk to people in the street, they've heard of it, and it was only launched in November of last year, so 6 months ago. Very, very soon after its launch, some of my friends, obviously too much time on their hands. One of them asked it if it could write an article on semiconductors in the style of Max Maxfield, which was a bit scary. Another friend in the UK, Joe Farr, he asked ChatGPT if it was possible to write a basic interpreter in C#. And it promptly did it in front of his eyes. He said it was scary to see the source code for the basic interpreter coming up.
Yep.
And it made some mistakes, like using basic keywords as variable names and things. But overall, he said it was an amazingly powerful effort.
Yeah,
And of course,
it gets
this
you 90% of the way in 10% of the time, right? This
Copilot that was, so the company that did ChatGPT is OpenAI, and OpenAI worked with GitHub to create Copilot, and that works with multiple languages: C, C++, C#, VHDL, Verilog. I think it's a plugin to VS Code. So for generating code, I found that Bard is giving more errorless code than ChatGPT. Interesting.
Yeah, interesting.
Yeah, the funny thing is, so I don't know why, but I've ended up with a lot of people called Bob in my life. There's a Bob in the office behind me. There's a Bob that I meet every Tuesday with a group of other friends to watch Doctor Who. I've got a master carpenter friend called Bob. There's Bobs everywhere, Bob for all seasons. And recently I was introduced to a company called MetaBob. And MetaBob's claim to fame, they told me something I never really thought before. And that was that generators like Bard and ChatGPT and Copilot, they're trained on vast amounts of source code. A lot of that source code is open source, and a lot of that open source has errors. And so as a result, they gave all sorts of numbers, like you could increase productivity. Well, they said that the average programmer spends 20% of the time thinking about what they're going to do, 30% of the time doing what they were thinking about, and then the remaining 50% of the time debugging what they just did. So half of the average developer's time spent debugging code. When you use ChatGPT or Copilot, you can increase your code generating productivity tremendously, but you also introduce a load of bugs. So now you've got to get those bugs out. MetaBob, the company, have got a tool called MetaBob, which is a generative AI that goes through your code, or code that you generated, or code that was generated by another AI, and it finds all the problems. And it's the same sort of interface where it highlights a problem and it shows you what its solution is and why it recommends it, and you can accept it and it fixes your code.
Pretty amazing.
We're moving into interesting times, as they say.
For sure.
Eric here says garbage in, garbage out is not a new technology. Yes, but it's AI. It's AI powered. Yes, you're right. So some Hot says Copilot was there before ChatGPT was released to the public. They may be using different AI approaches. Since they were both created by the same company, though, there's got to be a lot of stuff under there. And again, this is such early days. Yeah, and there's people. I'm sure that you, like me, have been hearing all the different stories. Like by February of this year, 30% of college students were using ChatGPT to help them write their papers for college. A university professor recently stopped all of his students from graduating in a certain class because he said that all their papers had been generated by ChatGPT. Unfortunately, the way he determined this was by asking ChatGPT if it had written the papers, and it happily said yes, even though it hadn't. And most recently, and then there's the ethical considerations. If you write code, or if you get ChatGPT to write code, is it ethically correct for you to then present it as something you created? Or if you write a book or use it to write a book or something. And the reason that one came up is that there's a lawyer who's very well positioned to answer this because he asked ChatGPT to help him create a brief. And he told it he wanted lots of. I used to watch Law and Order with Jack McCoy, where he goes through all the law books and find previous cases, Sullivan versus Reynolds, that backed up his argument. So he asked ChatGPT to come up with similar cases, and ChatGPT referenced all these cases that it had just made up on the spur of the moment. So when the judge went through trying to find these cases and they didn't exist, he questioned this lawyer quite sternly. And I think the lawyer's now going to go before the board to see whether he's going to keep his license or not.
Yeah, and should.
Again, we live in exciting times.
Yeah.
But I mean, so I've played around. So somebody here says, I think maybe one day some simple generative algorithm will be ported to TinyML and running on RTT. I don't know if you can. My impression is that maybe a simple generative algorithm. Again, some of the TinyML stuff. I generated my own little ML model that took 2K of code and it used the current sensor to determine when my vacuum cleaner bag was filled up. And the fact that you could generate that model in 2K of code was, again, it was auto generated and auto optimized and boiled down and everything.
Yeah.
So, Steve, anything else you'd like to discuss?
I think that's it from my side. I really appreciate the audiences and your time and attention as well, Max. I think this, from a going forward perspective, we'll see more from Infineon and specifically my product line in the RTT community in terms of support and presence. So again, I want to thank everyone and hope to see you all again.
Well, hopefully we'll see you next year.
Yeah, absolutely.